Think about how much of our planet you know. The countries. The capitals. The mountain ranges. The great rivers. Here's the thing, though. We have better maps of Mars than we have of the ocean floor. The surface of the Moon has been mapped at higher resolution than most of Earth's deep ocean. 80% of the world's oceans remain unexplored. Not approximately. Not mostly. 80%. The ocean covers 71% of the planet. It is the dominant feature of this world. And we barely know it. If you're listening to this to fall asleep, perfect. Tonight we're going somewhere most humans have never been. Drop a comment if you want. Where are you listening? What ocean is nearest you right now? Let's start with what we do know. Because what little we've found is extraordinary. The ocean is not one thing. It's a layered world of completely different environments. The sunlit zone extends to about 200 meters. This is where almost all ocean life visible to humans lives. Below 200 meters, sunlight disappears. In the twilight zone, bioluminescence replaces sunlight. Creatures here have evolved light-producing organs, giant eyes, and transparent bodies over millions of years. Below 1,000 meters is the midnight zone. No light at all. Crushing pressure. Near freezing temperature. And yet it teems with life. Life that has found ways to thrive in conditions that should be impossible. The abyssal plain begins at about 4,000 meters. It covers more than half of the ocean floor. More scientists have walked on the Moon than have visited the abyssal plain. And then there are the trenches. The true deep. Places so profound they make Everest look modest. The Mariana Trench is 11 kilometers deep. It's in the western Pacific. And almost nothing lives there, we thought. In 1960, 2 men in a Trieste submarine descended to the bottom of the Mariana Trench. No one would do it again for 52 years. When James Cameron finally descended again in 2012, he found something startling. The deepest point on Earth was not barren. He found amphipods, shrimp-like creatures, in vast numbers. Feeding on organic material that drifts down from the surface miles above. He found snailfish, the deepest living vertebrate, thriving at depths we assumed were lethal. Every time we've sent cameras to the deep, we've found life. Every single time. But the most profound discovery in deep ocean came in 1977 on the East Pacific Rise. Scientists in the Alvin submarine expected to find a cold, dark, essentially lifeless seafloor. What they found changed biology forever. Hydrothermal vents. Cracks in the seafloor where superheated water jets into the ocean at temperatures of up to 400 degrees Celsius. And around those vents, despite the absence of sunlight, despite the lethal heat and chemical toxicity, life exploded. Tube worms 3 meters long. Colonies of white crabs. Mats of bacteria so thick you could hold them in your hand. None of this ecosystem runs on sunlight. It runs on chemosynthesis. Chemistry, not photosynthesis, at the base of the food chain. This discovery proved that life doesn't need sunlight. It needs energy. Any energy. This changed how we think about where life might exist elsewhere in the solar system. Suddenly, every ocean world became a candidate. Europa, Jupiter's moon, has a liquid ocean beneath its ice. Hydrothermal vents may exist there. Life may exist there. But back to our own ocean. The species question. Scientists estimate there are between 700,000 and 1 million species in the ocean. We've described roughly 240,000. That means the majority of oceanic species alive today have never been seen by human eyes. Every deep-sea expedition returns with new species. Every single one. Without exception. In 2023, a single 2-week expedition to a seamount off Chile found over 100 species new to science. In 2024, a survey of the deep Pacific floor found organisms that may represent entirely new branches of the tree of life. We may be sharing this planet with forms of life that are as evolutionarily distant from us as plants are from bacteria. Here's where the ocean and the human story connect. Your ancestors crossed it. At least 65,000 years ago, humans crossed open water to reach Australia. Multiple crossings. Families. Supplies. The closest land was still 90 kilometers away. Out of sight. These were deliberate voyages into the unknown. They navigated by stars, by swell direction, by the behavior of birds, by the smell of vegetation on the wind. This knowledge, reading the ocean like a landscape, was encoded in languages, songs, and the body memory of navigators. Polynesian navigators crossed the largest ocean on Earth to reach Hawaii. 4,000 kilometers of open water. No instruments. No maps. They were the greatest navigators in human history. Their knowledge of the ocean was encyclopedic. And most of it is gone. But some survived. Maupielug of Micronesia kept the ancient knowledge alive when it was on the verge of extinction. He taught it to a new generation. In 1976, a traditional Polynesian sailing canoe crossed from Hawaii to Tahiti without instruments. The knowledge lived. The ocean isn't just a body of water. It's a planetary engine. The world's oceans are connected by a single circulatory system. Scientists call it the thermohaline circulation. Others call it the ocean conveyor belt. Cold, dense, salty water sinks in the North Atlantic. This drives a current that carries warm water from the tropics all the way to northern Europe. Without the Gulf Stream, London would be as cold as Newfoundland. Paris would be more like Labrador. The ocean heats an entire continent. This circulation takes roughly 1,000 years to complete one cycle. The water you see in the North Atlantic was last in the Pacific 1,000 years ago. Climate scientists are watching the Atlantic circulation slow. It hasn't been this slow in over 1,000 years. If the conveyor stops, models suggest temperatures in northern Europe could drop dramatically within decades. The ocean regulates everything. The ocean doesn't just regulate temperature. It holds 50 times more carbon than the atmosphere. It is Earth's primary carbon reservoir. The deep ocean is so cold that carbon sinks to the bottom and stays locked away in the sediment for thousands of years. El Niño is a disruption of the Pacific's normal current pattern. It affects weather across every continent. Floods in Peru, droughts in Australia, altered storm tracks globally. The ocean doesn't just affect weather. It creates it. 90% of the moisture in Earth's storms comes from ocean evaporation. Hurricanes, typhoons, cyclones, they are all powered by warm ocean water. The ocean releases its stored solar energy as catastrophic weather. Let's go back to the sunlit zone. To a world most people know exists, but few understand. Coral reefs cover less than 1% of the ocean floor. They support 25% of all marine species. Coral reefs are the rainforests of the sea. Biodiversity per square meter that rivals any ecosystem on Earth. But a coral reef is not rock. It is a living animal. Each coral polyp is a tiny creature with a mouth and tentacles and a skeleton. Coral polyps are in a symbiotic relationship with algae called zooxanthellae. The algae live inside the coral and provide up to 90% of its energy through photosynthesis. When water gets too warm, the coral expels its algae. The reef turns white. This is called bleaching. A bleached coral is not dead. It is starving and stressed. If the water cools in time, it can recover. If not, it dies. In 2016 and 2017, consecutive mass bleaching events damaged over half of the Great Barrier Reef. The largest coral system on Earth, stressed in 2 consecutive years. The Great Barrier Reef is so large it is visible from space. It took 10,000 years to build. Some sections won't recover in our lifetimes. Reefs are also pharmacies. Coral reef organisms have given medicine several drugs, including treatments for cancer, HIV, and chronic pain. One compound from a reef sponge became the basis for AZT, one of the first drugs to treat HIV. The reef saved millions of lives. And yet we're letting reefs die. For fish. For tourism. For coastal development. For temperature. Now let's talk about something that will change how you hear the ocean. Sound. Water is extraordinarily good at transmitting sound. In water, sound travels 4 to 5 times faster than in air. Before humans made the ocean noisy, whales could communicate across entire ocean basins. A whale in the North Atlantic could talk to one in the South Atlantic. Blue whales produce sounds at frequencies so low humans can't hear them. But they carry thousands of kilometers through deep ocean channels. The SOFAR channel. The sound fixing and ranging channel. A layer of water at about 1,000 meters depth where sound can travel extraordinary distances. Whales evolved to use this channel. Their songs travel in the SOFAR channel, bouncing between pressure boundaries, propagating across the ocean. Humpback whales compose. They change their songs seasonally and geographically. A new song that starts on one side of the Pacific spreads to the other within a few years. Sperm whales have dialects. Different groups have different patterns of clicks. Family dialects passed down through generations. Orcas also have dialects. Each pod has a unique call repertoire. Researchers can identify individual pods by sound alone. In 2023, researchers used AI to analyze sperm whale click sequences. They found a combinatorial communication system with a complexity that may rival language. We may be sharing this planet with creatures that have complex language and we never knew, because their conversations happen in the deep ocean at frequencies we can't hear. Now ocean noise from ships, sonar, and drilling has reduced whale communication ranges by up to 90%. A conversation that once crossed oceans now might only reach across a bay. The history of ocean exploration is a history of courage meeting the absolute unknown. The first scientific ocean expedition was the HMS Challenger voyage of 1872 to 1876. It mapped the deep ocean floor for the first time. The Challenger crew dredged the ocean floor and found life at every depth. Their work was so comprehensive that modern oceanography still uses their data. Their greatest discovery, the Mariana Trench. They measured water depths that seemed impossible. Almost no one believed them. Jacques Cousteau invented the aqualung in 1943. Before that, humans could dive to perhaps 30 meters using breath alone. Cousteau brought the ocean into living rooms. His TV series reached 300 million viewers. An entire generation fell in love with a world they'd never seen. Sylvia Earle set the record for the deepest solo dive in 1979 at 381 meters. She walked on the seafloor without a tether, alone, in a pressurized suit. She called what she saw staggering. An entire forest of coral. Fish no one had documented. A world the size of a continent, unvisited. Earle has spent more than 7,000 hours underwater. She says the ocean is in trouble, and almost no one understands how serious. Robert Ballard found the Titanic in 1985 using a remotely operated vehicle. He realized ROVs could explore where humans cannot go. Today, ROVs can reach the deepest trenches. But we've sent them to perhaps 1% of the deep ocean floor. The remainder, unknown. There are currently more deep space telescopes pointed at distant galaxies than there are deep-sea submersibles capable of reaching the abyss. Let's go deeper into one of the ocean's most extraordinary features. The living light. Bioluminescence is the production of light by living organisms. In the ocean, it is not rare. It is the norm. Scientists estimate that 76% of deep-sea animals produce bioluminescence. It is the most common form of communication in the ocean's dark zones. Bioluminescence comes from a chemical reaction between a compound called luciferin and an enzyme called luciferase. The same chemistry, evolved independently over 40 times in different lineages. It evolved independently because it solves deep-sea problems that nothing else can. Finding a mate in total darkness. Luring prey. Confusing predators. The anglerfish uses bioluminescence to lure prey. A glowing appendage dangled in front of its massive jaws in total darkness. Some squid can flash specific patterns of light to communicate. Researchers have documented squid conversations using light on their skin. The vampire squid lives at 700 meters and produces bioluminescent clouds to confuse predators, the same strategy land animals use with ink, but with light. Some bacteria are bioluminescent. They colonize fish tissue and create a permanent glow. In exchange, the fish provides nutrients. When you sail through warm tropical ocean at night and the water glows blue, that's billions of bioluminescent plankton being disturbed by your passage. Bioluminescence at the surface is well studied. Bioluminescence in the deep ocean remains one of the least understood phenomena in biology. The ocean floor is not flat and featureless. It is the most geologically dramatic landscape on Earth. The mid-ocean ridge system is the longest mountain range on Earth. 65,000 kilometers long. Mostly beneath the ocean. The mid-Atlantic ridge runs down the center of the Atlantic like a seam. It is where two tectonic plates are moving apart. The ocean is growing. Iceland sits on the mid-Atlantic ridge. It is one of the few places on Earth where a mid-ocean ridge breaks the surface. Seamounts are underwater mountains that don't break the surface. There are estimated 100,000 seamounts in the ocean. We've visited fewer than 500. Seamounts create upwellings of nutrient-rich water. They become oases of life in the otherwise barren deep ocean. Some seamounts have species found only on that single mountain. Species that evolved in isolation over millions of years and live nowhere else. The process of seafloor spreading means that the youngest ocean floor is at the mid-ocean ridges, and the oldest is at the subduction zones, where it's swallowed back into the mantle. The oldest ocean floor on Earth is about 280 million years old. For comparison, the continents have rock that is 4 billion years old. The ocean floor is constantly recycled. The ocean is a chemical system of staggering complexity. And right now, its chemistry is changing. Seawater contains virtually every element on the periodic table. The ocean is a dilute mineral soup. Including gold, about 20 million tons of dissolved gold in the ocean. The ocean has a pH of about 8.1. Slightly alkaline. Life in the ocean evolved around this chemistry over hundreds of millions of years. Since the Industrial Revolution, the ocean has absorbed so much CO2 that its pH has dropped by 0.1 units. That sounds small. It means 30% more acidic. Ocean acidification dissolves shells. Oysters, clams, sea urchins, corals, their shells and skeletons are made of calcium carbonate, which dissolves in acid. Pteropods, tiny swimming sea snails at the base of the ocean food web, are already dissolving in parts of the Southern Ocean. Their shells disappearing in their own lifetime. Dead zones are areas of ocean with so little oxygen that almost nothing can survive. They're created by nutrient runoff from agriculture causing algae blooms that then deplete oxygen. The Gulf of Mexico dead zone is the size of New Jersey. It returns each summer. Shrimp, fish, and crabs flee or die. There are now over 500 dead zones in the world's oceans. In 1960 there were fewer than 50. The chemical health of the ocean is declining. In 1997, a sailor named Charles Moore was crossing the Pacific when he noticed something he couldn't explain. For days, he sailed through a soup of small plastic fragments. There was no land for 1,000 miles. Where was it all coming from? What he'd found is now called the Great Pacific Garbage Patch. It's not actually a solid island. It's a concentration of microplastics spread across an area twice the size of Texas. Microplastics are now found in the deepest trenches. In fish. In plankton. In sea salt. In drinking water. In human blood. Scientists have found microplastics in the Mariana Trench at 11 kilometers depth. The most isolated place on Earth. No longer pristine. Every year, 8 million metric tons of plastic enters the ocean. That's equivalent to dumping a garbage truck's worth of plastic into the ocean every minute. Albatrosses feed plastic to their chicks. The parents can't tell the difference between plastic fragments and fish. The chicks starve with full stomachs. There is a rush happening right now. A gold rush. Except it's on the ocean floor, and the gold is manganese nodules. Polymetallic nodules form over millions of years on the abyssal plain. They contain the metals needed for electric vehicles and renewable energy infrastructure. The Clarion-Clipperton Zone in the Pacific may contain more nickel and cobalt than all known land-based deposits combined. Mining companies want to deploy machines the size of houses to vacuum up the seafloor. The ecosystem has never been studied. The impact is unknown. A single pass of a mining machine disturbs sediment plumes that spread for hundreds of kilometers. The plume can smother life far beyond the mining site. The organisms that live on and among the nodules grow at rates of millimeters per million years. If disturbed, the ecosystem will not recover within any human timescale. A study revisited a mining test site 26 years after a small test. The seafloor showed no recovery. The tracks of the machine were still perfectly visible. The debate, mine the ocean floor for metals to build clean energy infrastructure, or protect an unexplored ecosystem we don't yet understand. There is no easy answer. Above the abyssal plain, closer to shore, there is another world that is almost as poorly understood. The kelp forest. Giant kelp is the fastest growing organism on Earth. It can grow 60 centimeters per day under ideal conditions. A kelp forest is a three-dimensional city. The canopy, the middle column, the seafloor. Each zone with completely different species. Sea otters are the keystone species of the kelp forest. Without them, sea urchins eat the kelp, the forest collapses. When sea otters were hunted nearly to extinction for their fur in the 18th and 19th centuries, kelp forests from California to Alaska collapsed. When sea otters were reintroduced and protected, the kelp forests came back. An entire ecosystem rebuilt by a single species. Kelp forests sequester carbon at extraordinary rates. And they are disappearing. Climate warming, urchin barrens, and urchin disease are eliminating them. Off California, 95% of the historic kelp forest has disappeared in some regions over the past decade. One of the most productive ecosystems on Earth, lost. The ocean we know today is not the ocean that always was. Earth has had many oceans. 4 billion years ago, the entire Earth may have been covered in ocean. A global ocean with no land at all. Life began in the ocean. The first cells appeared in the ocean roughly 3.8 billion years ago. Every living thing on Earth is descended from ocean organisms. For 3 billion years, all life was ocean life. Land was bare rock, scoured by ultraviolet radiation. The ocean was the only refuge. The first organisms to colonize land came from the ocean. The ancestors of all land plants. The ancestors of all land animals. Ocean emigrants. Fish crawled onto land 375 million years ago. Tiktaalik, discovered in 2004, is the transitional fossil. A fish with protolimbs, capable of pushing itself out of water. All tetrapods, amphibians, reptiles, birds, mammals, including humans, are descended from a fish that walked out of the ocean. This means your hands, your fingers, are modified fish fins. The same bones, shaped by 375 million years of evolution for a different purpose. Some 250 million years ago, the Permian Ocean was hit by the greatest extinction in Earth's history. 96% of marine species disappeared. The Great Dying, as it's called, nearly ended complex life. It took 10 million years for ocean ecosystems to fully recover. But the ocean recovered. It always recovers. Given time. Given conditions. Life finds its way back into the water. Sea level itself has been radically different throughout Earth's history. During ice ages, sea levels dropped 120 meters. Entire continental shelves became dry land. The English Channel was dry land 20,000 years ago. Humans walked from Britain to continental Europe across what is now seafloor. Doggerland, the land that connected Britain to Europe, flooded 8,000 years ago as glaciers melted. Entire communities displaced by rising sea. The ocean has been rising and falling for billions of years. Right now, it is rising again. But faster than at any point in the last 3,000 years. There is a theory about human evolution that places the ocean at the center of our story. The aquatic ape hypothesis, controversial, but persistently interesting, argues that humans spent a critical evolutionary period near or in water. Humans are the only primate that instinctively holds its breath in water. Human infants will hold their breath and move their limbs in a swimming motion if placed in water. Humans have unusually thick subcutaneous fat compared to other primates. We are nearly hairless. We have descended larynxes allowing breath control. Traits more common in aquatic mammals than land apes. More widely accepted, coastal living drove human brain development. Seafood contains DHA, a fatty acid critical for brain growth. Our large brains may be a gift from the ocean. Archaeological sites along ancient coastlines reveal that early humans were eating seafood and living by the sea at least 164,000 years ago. Blombos Cave in South Africa. Our brains contain the same ratio of omega-3 to omega-6 fatty acids as marine animals. Not land animals. Marine animals. We cry salt tears. Our blood is salt water. When we sweat, we lose the same minerals as sea water. Our bodies remember the ocean. There is a word in Japanese, thalassophilia. The love of the sea. The instinctive pull that many humans feel toward the ocean. Research shows that proximity to the ocean reduces stress, improves mental health, and produces measurable physiological calm. We don't just enjoy the ocean. We need it. Maybe that pull you feel when you see the ocean is evolution speaking. A 3 billion year memory. Your cells recognizing where they came from. The deep ocean isn't just mysterious. It's essential. The ocean produces over half of the oxygen you're breathing right now. Phytoplankton in the sunlit zone. The ocean absorbs about a quarter of the CO2 humans produce. Without it, climate change would be dramatically faster. The deep ocean species contain compounds that may become medicines we haven't discovered yet. Several cancer drugs already in use came from marine organisms. Citarabine from a Caribbean sponge. Ziconotide from a cone snail. We're mining the ocean floor for rare metals before we've mapped it. Before we know what we're destroying. But here is something the history of the ocean teaches us. Life is extraordinarily resilient. Marine protected areas, when properly enforced, allow ecosystems to recover with startling speed. In 1994, the Channel Islands National Marine Sanctuary was given full protection. Within 10 years, fish biomass inside had increased by 500%. The ocean has recovered before. From the Permian extinction. From asteroid impacts. It has a depth of resilience that exceeds our capacity to fully damage it, if we give it time. Sylvia Earle launched a mission called Hope Spots. Networks of protected ocean that together could stabilize the entire marine system. If we protect 30% of the ocean, models suggest the entire ocean system can stabilize. 30%. In 2023, the UN High Seas Treaty was signed. The first international agreement to protect ocean beyond any nation's borders. A start. The deep ocean is not gone. It is not beyond saving. It is simply unknown. And unknown things can still be protected. Every species we describe, every event we photograph, every current we map, is a species, event, a current we might decide to protect. Knowledge is protection. The ocean that your ancestors crossed, that your body chemically remembers, that gives you half the oxygen in every breath, it is still there. Most of it unknown. Most of it unnamed. Most of it alive, working, resilient, and ready to be discovered. As you drift toward sleep, let the ocean accompany you. Somewhere below the surface of the nearest ocean, creatures are hunting in total darkness. Hydrothermal vents are building ecosystems that have never encountered a human. Communities that may be millions of years old. Squid the size of buses are moving through the midnight zone, too large and too deep for any net ever deployed. Somewhere, possibly, creatures are alive that have never been seen by human eyes. Will never be, if the ocean is damaged before we find them. This ocean was here when your ancestors first crossed it. It remembers the 65,000-year-old wakes of their boats. It will be here long after we're gone, continuing its work of giving life to a planet. Tonight, while you sleep, the ocean is working. Processing carbon. Producing oxygen. Cycling nutrients. Most of it in darkness. Most of it unnamed. Most of it as unknown as it has always been. Somewhere on Earth right now, an ROV is descending for the first time into an unvisited part of the seafloor. Scientists are watching footage of creatures no human has ever seen. Somewhere a blue whale is singing in the Sofar Channel, its voice carrying thousands of kilometers through cold dark water to other whales who may never meet. Somewhere a vent community that has existed for 1,000,000 years is cycling life through superheated water, entirely independent of sunlight, entirely independent of anything humans have ever done. Somewhere a squid of extraordinary size is hunting in the midnight zone. We know it exists because we found its beaks in sperm whale stomachs. We've never photographed one alive in its habitat. The ocean holds this much mystery in a world where mystery is increasingly rare. It is the last truly unknown place on the planet we call home. Let your breath slow now. Let it become like waves. Each inhale, the ocean surface rising. Each exhale, it settling back. You are made of ocean water. The salt in your blood. The minerals in your bones. You are not separate from the ocean. You carry it with you. Think about the water molecule in your blood right now. It may have been in the Tethys Sea 200 million years ago. In a Jurassic ocean. In a dinosaur's blood. The same water has been cycling for 3.8 billion years. The ocean you see is the same ocean life began in. Nothing new has been added. Nothing has been lost. Every raindrop was once ocean. Every cloud is borrowed sea. Every river is the ocean returning to itself. Picture the ocean breathing tonight. The tides rising in the dark. The deep currents flowing slowly toward their 1,000-year return. Let the weight of 11 kilometers of dark water be the weight that holds you down into sleep. Let the ancient ocean carry you into rest. Rest now. The ocean is older than any question. Deeper than any fear. And tonight, it holds you too.